Lab 4, Oscillations, Physics 2211. Introduction. A mass attached to a fixed spring is stretched and then released. This is in hopes to model the world's largest rope swing. I used Tracker to plot the position data. I created a model using GlowScript to track and analyze the motion of the object. I then compared predicted motion to observed motion. In my GlowScript code, I was able to plot energy changes. Main physics ideas. Newton's second law, forces, where F net equals F grav plus F spring, F grav equals mg, and F spring equals ks, energy, where delta E of the system equals delta K plus delta US plus delta UG, and delta E system equals 0. Energy continued, where K equals 1/2 mb squared, UG equals mgh, and US equals 1/2 ks squared. Initial conditions. Mass equals 0.402 kilograms. Initial position is negative 0.02083, negative 0.85107, 0 meters. Initial velocity is 0,0,0 meters per second. I found the average t using y values for the first 3 periods and got t average equals 1.52 seconds. I then used the equation t equals 2 pi times square root of mass divided by k and solved for k. This yielded k equals 6.8 newtons per meter. I then determined L naught equals 0.63 meters from video analysis. Lastly, I used the equation L naught equals L hat minus mg divided by k to solve for L. This yielded L equals 0.12 meters. GlowScript Part 1. Firstly, I entered my initial conditions. Then I calculated the different components of the spring force. Lastly, I calculated initial energy. GlowScript Part 2. First, I calculated all the forces acting on the mass. I then used the position and velocity update formulas. I then updated the spring force. Lastly, I updated the time for every loop. GlowScript Part 3. Finally, I calculated the net change in energy for each frame. Display of data. In the first graph, the red line represents delta UG, the orange line represents delta E, the blue line represents delta K, and the green line represents delta US. In the second graph, the red line represents the actual experiment, and the blue line represents the GlowScript model. What does it mean, Part 1? Question. For your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. Yes, the energy principle is satisfied. This is because delta E equals 0. This can be seen in the graph on the previous slide. This is because the orange line, which represents delta E, is always 0. This also indicates a closed system. What does it mean, Part 2? Question. Using the data you obtained in Tracker, make 2 separate estimates of oscillation periods. First from the X position data, and second from the Y position data. Compare and discuss. Answer. The X oscillation period was 1.6 seconds. The Y oscillation period was 1.5 seconds. The 2 estimates are very similar because the oscillation period only depends on the object's mass and the spring constant K. The small difference between the 2 is most likely due to my own error when I was plotting the object's position in the tracking software. Concluding thoughts. The computational model and the experimental model yielded very similar results. The small deviations in the results are likely due to human error when using Tracker to plot location. If I were to do an alternate experiment, I would conduct the same experiment on a much bigger scale. I would be interested to see how the results would vary. Thank you for listening to my lab report.